We are building the first real multi-execution engine blockchain, named WasmX. I have showed WasmX plugins for Python, JavaScript, Golang smart contracts, along the already known EVM and CosmWasm execution engines, and all of these languages become first-class smart contract languages, and all of them can collaborate on the same chain. All of this is possible due to our meta contracts, which are core smart contracts in WebAssembly that extend the blockchain and are governed and upgraded by consensus. So you can add any language to the blockchain if you add a meta contract for that language. And WasmX provides the various standards used in practice for executing WebAssembly modules. So you can execute modules built with TinyGo, AssemblyScript, and other compilers. This is a WasmX Python contract. And today you will see some of the blockchain integrations that we have made available for Python devs. Much of this code can be abstracted out by the WasmX SDK, but this gives you some insight into how it works. We have a main entry point here into our contract, and then several functions that can read blockchain environment variables, write and read contract storage, and instantiate new contracts. For example, the two instantiate account methods use the WasmX provided instantiate and instantiate2 endpoints with a code ID, an initialization message, and a balance. The store and load functions store and load from the contract storage. The getCode function retrieves the code, the source code for a contract address. getAccount retrieves account information for a specific contract address. getEnv retrieves the environment of the blockchain, for example, information about the chain itself, like the chain ID, the current caller or sender of a transaction or query, and so on. And we also, in the instantiate entry point, we set the owner of this contract as being the caller, which means the account that makes the deployment transaction. More specifically, who makes the instantiation transaction. And we will take this code and deploy it on our Mythos testnet. And here we have a dApp to do just that, and in previous videos we have showed this process in more detail. We will just paste the code here, and we have our Kepler wallet connected to our Mythos 15 testnet. And we also have an explorer for this testnet right here. So if we copy our current address, we can see our account here. Now we instantiate this contract, and we first need to store the code. We have a transaction for storing the code, and we get a code ID in return, and the next transaction will use this code ID to instantiate the contract and get a contract address. So we can see that our code ID is 23, and we should already see the transactions going on here, and we can look, for example, this is the instantiation transaction. And this is our contract address that should have been already filled in here. And now we can query some of these contract functions. For example, we can query getOwner, and we communicate through the JSON format. So This is the arguments that we are sending. And this is the answer. This is the address of the contract deployer that was stored at instantiation time as part of the contract logic. And this should be our address, and it is. Next, we can see get caller. And it's the same address because we are using the same account. Next, we can try get chain ID. And we get the current chain ID, which is correct. It's the same as the one showed by the Explorer. We can also try get balance with an address, and we will copy our own address here in string format because this is how we coded the get balance function. And this is our balance. The decoding is not correct in this case because this is not UTF-8 encoded, but it is a hex string of our actual balance. We can also try get account, and we will use our current contract, and we actually get a UTF-8 encoded JSON string, and we can see the address in bytes encoding, so it's not a beg32 formatted string like this. The code hash also as a byte array, the code ID, and this is the internal dependency on the system. So this source code that we have uploaded is dependent on the meta contract that has this exact version. And if we try out get code, we should get the actual source code of this contract. And it's UTF-8 encoded, and this is the source code of the contract. In future versions, we will also support working only with Python bytecode or JavaScript bytecode. And now we can try out one more thing. We can try the instantiate account method, and we need a code ID first. We can use the same code ID as our contract, which is 23. So the code ID of an already deployed contract. And then an instantiation message, which for now is empty. We don't need any arguments in the instantiate method for this contract. And then we need a balance. In this case, it will just be 0, and we give the balance in hex format over 32 bytes. So this is how it looks, and we will execute this. But we need to increase the fee for the transaction. So the problem is that we used an empty initialization message here, but what we need to provide is a hex encoded JSON string that contains the field data with an empty value. And this is what this hex string is. So now we will try to execute again. And now we have our result. And we can go to the Explorer and actually see the transaction here. This was an execution transaction through the message execute contract WasmX message. But we also see here in the events, we see an event of type instantiate with a contract address. So this is the address of the contract that was just instantiated. And we should be able to see that address in all of these logs here. And this is it. And if we go one step further, we should remember this address of the factory contract, because we should see this address as an owner of the contract that was just created. Because as you remember, in the instantiate function, we set the owner, which is the direct account that called the instantiation transaction. So let's load the new contract address here and then call getOwner. And this is our previous factory contract address. Future demos will only get better and better, and you will see blockchain technology being used in incredible ways.